Hello, good day. Once again, you're welcome back here in this virtual class. We're looking at the integral Secx dx. Okay, please, I want you, those of you haven't subscribed to my channel. Once you click on this link, to direct you to my YouTube channel. Please help me subscribe. Also hit the notification button so that when similar video like this surfaces, you'll be able to have access to them. Now, what is Secx? Sec is the inverse of cos. So we know that Secx is 1 over cos. We replace Secx with 1 over cos x. And this become integral 1 over cos x dx. Now, here we will look for an expression for cos x from the double angle. First of all, from the compound angle, we are aware that cos theta plus alpha is equal to cos theta cos alpha minus sin theta sin alpha. Now, if we let theta is equal to x over 2 and the alpha is x over 2, that is from double angle, this becomes cos open bracket x over 2 plus x over 2 close bracket is equal to cos s over 2 cos s over 2 minus sin x over 2 sin x over 2. So here, this x over 2 plus x over 2 is x. Okay, the denominator are the same. S plus s is 2x. So 2s divided by 2 is x. So that the left hand side here become cos x. So because we are looking for an expression for cos x, the right hand side here, this cos x over 2 cos s over 2 is cos square x over 2. Cos sin x over 2 times sin x over 2 is sin square x over 2. Okay, here the expression become 1 divide cos square x over 2 minus sin square x over 2 dx. Okay, for us to move further, we need to find do some manipulation here by dividing both numerator and the denominator of the integral here by cos square x over 2. So that this becomes 1 over cos square x over 2 divide cos square x over 2 divide cos square x over 2 minus sin square x over 2 divide cos square x over 2. Now, but you recall that 1 over cos is sec and sin x over cos x is tan x. So that this expression at the numerator here becomes sec square x over 2. And here, cos square x divided cos square x is 1. Then sin over cos is tan. So, and this becomes tan square x over 2 dx. Okay, now for us to move further, we need to find an expression for the x. Since we need to find an expression for the x, first and foremost by letting tan x over 2 equals t. And this is labeled as equation 1. So the expression becomes sec square x over 2 minus 1 over t square dx. Then, for instance, like I said, for us to obtain, we need to find expression for dx by differentiating equation 1 with respect to t. Okay, with respect to t. So you see, this function itself is a function of another function. So here we're going to make use of the chain rule or function of a function. So by first of all letting the term here x over 2 is equal to u, so that t is equal to tan u. Then for us to obtain the x, or for us to obtain the x, we have to differentiate the start equation with respect to t, and this becomes the t over the s is equal to the t over the u times the u over the s. Okay, so that the u the s is equal to 1 over 2, and the t the u is equal to sec square x sec square u. So the derivative of tan is sec square or any variable. Okay, here the t over the s is equal to 1 over 2. So obtain here, which is the u ds times the t the u, which is sec square s over 2. Now to obtain the x, multiply both sides by 2 dx over sec square s over 2. Okay, so we multiply because we're trying to make the s subject of relation. We could simply cross multiply um, and use this approach. So this become, if we do that, this becomes dt over the s times 2 ds over s square x over 2 is equal to 2 ds divide s square x over 2 times half times s square s over 2. So here we can see s square s over 2 go up with s square s over 2. 2 cancel 2. What is left on the here is d, which is written here. Then on this side, the s go off with the s. Here we have a 2, the t s square s over 2. Okay, that is the value of the x. Okay, we substitute it in this equation, and this become integral s square x over 2 divide 1 over t square times 2 the t divide sec square x over 2. So we are trying to eliminate sec square s. Everything that has to do with s need to be gotten rid of. Okay, so that the expressions turn out to be integral to divide 1 over t square dt. So here, observing the denominator carefully, you see this is a difference of 2 squares. So, and this expression can be expressed as 1 over t into 1 minus t. 1 plus t into 1 minus t. So here, for us to move, now we need to use the fraction here, we need to express it in partial fraction. So we use the integration by partial fraction here. So the expression become 2 into 1 plus t into 1 minus t is equal to a divide 1 plus t plus b divide 1 minus t. Okay, once an expression is given like this, you can express it in form of partial fraction as the first denominator here could be a over 1 plus t, then the other one is b over 1 minus t. Then for us to clear this fraction, we multiply through by the LCM, which is 1 plus t into 1 minus t. And what this is applied to this becomes 2 on the left hand side. And what is left here become a into 1 minus t, close bracket, plus b into 1 plus t. Now to obtain b, we will let a into 1 minus t is equal to 0. And so that t is equal to 1. And if t is 1 is substituted here, you see that this one is blown off, and what is left here is 1 plus 1. That will give us 2b is equal to 2. So 2b is equal to 2, so that b is equal to 1. Similarly, for us to obtain a, we will let b is equal to 1 plus t equals 0. And if that is done, you see that this becomes 2 into a into 1 minus 1, close bracket, plus b into 1 minus 1. Okay, so here we have minus 1 minus 1. Here we have a 1 minus 1. So that here become 2 is equal to minus 2a, a is equal to minus 1. And if this is expressed, it's become 1 integral 1 over 1 minus t dt minus integral of 1 over 1 plus t dt. Then the integral of this nature can easily be integrated using a fraction in form of 1 over x. So this become integral of ln open bracket 1 minus c close bracket minus ln 1 plus t close bracket. Here this is logarithm, and once it is minus, the appropriate formula is, since the bases are the same, is to divide. So that this logarithm here, this integral ln 1 minus c minus ln 1 plus c is equals to 1 minus c log ln 1 minus c over 1 plus t plus c, where c is an arbitrary constant. Okay, but you recall that we said that let it t is equals to another variable. Okay, so what is the value of t? Look at what is value of t. T is equals to tan x over 2. So we replace it with tan x over 2. So that here we see that the integral becomes ln absolute value 1 minus tan x over 2 divide 1 plus tan x over 2 absolute value close plus c, okay, where c is an arbitrary constant. But 1 minus tan x over 2 divide 1 plus tan x over 2 is equals to sec x plus tan x. So therefore, the integral sec x dx is equals to sec x plus the absolute value of sec x plus tan x plus c, where c is an arbitrary constant. Please, if you like this video, please help me share it. In my next class, I will explain why sec x plus tan x is equal to 1 minus tan x over 2 divide 1 plus tan x over 2. See you in my next version class. Have a nice time and have a lovely day.